Welcome at our session called Mastering Network Detection Response. In this session, I will take you through basic concepts, principles, and recommendations for configuring Flowmon ADS, our network detection response tool that is part of the Flowmon product family. My name is Pavel, and I'm responsible for the Flowmon product line as a product manager. And I will take you through these slides and couple of practical exercises as well. This session is mostly designed for current users of Flowmon ADS to better understand how it works, what are the underlying principles, to give guidance on proper configuration and tuning. But I believe it will be also useful for those who are just considering this technology for adoption. The agenda. We will start with basic terminology. We will explain key building blocks of ADS, and then we will move to architecture and data processing, so you will better understand different layers of data processing and data analysis. And then we will take some time on how to tune the detection capabilities, so you will produce the meaningful events in your environment. Through the whole slides, I have a couple of practical exercises, so I will be jumping to the user interface and I will be showing those practical exercises directly in the application. Let's start with the building blocks and with the terminology. So first concept that you need to understand is called data feed. The data feed in the context of ADS is a logical grouping of network telemetry data that belongs together, that represent a single logical network segment, such as internal LAN or DMZ or a branch office. So with data feeds, you can split your network traffic logically, and this is required to properly analyze the traffic in different logical segments. Because what you want to do is usually to apply different set of detection rules on different network traffic. You want different sensitivity of the detection methods, and you also want to have different baselines and different metadata for these different network segments, which is exactly what is happening in the background. So each and every data feed is processed independently from the others, and all the baselining and all the detection is independent between the data feeds. What is the source of the data for the data feed? It's actually data on the collector that lives in a profile and that's composed of multiple channels. So what you are doing, you're mapping data feeds to data sets that are stored on the collector. And these profiles and channels allow you to slice and dice the data according to your network segmentation and according to how you want to process that data in the anomaly detection system. So that's the concept of data feeds. Another concept is called filters, and that's a way how to explain to anomaly detection system what are the major network subnets in your environment, what are the key servers, what is DNS, what is DHCP. So this way you're providing knowledge to anomaly detection system about your environment. To work with the filters in an easy way, we have created a concept of atomic filters and relation filters or relational filters. In atomic filters, you're simply defining individual subnets, individual IPs. So you're listing very specific servers or specific subnets. And in relational filters, you're using set operations to group those filters to, for example, say my server segment is composed of this subnet, that subnet, and another subnet. So with this concept, you can keep your filter structure logical. And when you need to update some information, you just update the specific IP address in an atomic filter, and it's automatically propagated to all the other filters where this atomic filter is actually being used. So this way you can avoid duplicates in filter definition, and you don't need to then make multiple changes in different filters. So that's going to be our first exercise. What I recommend you to do in your anomaly detection system is looking at your filters, looking at how you have defined those filters, if you have any duplicates. Maybe you can split it into atomic filters and recreate the filters again. So that's what I recommend you to do after the session. Now what we are going to do together, we will review my configuration, and I'll show you how you can create a relational filter based on the existing configuration. So we will create a filter that will list all the IPs that are not part of my internal LAN. So let me switch to live demo. I'll go to the anomaly detection system and I'll go directly to the settings and to filters. So what you can see here is that I have defined 15 atomic and 6 relational filters. And when we look at atomic filters, you can see that I'm basically describing what I have in my environment, either internal or external addresses. And in relational filters, I'm actually using those atomic filters to define more high-level logical constructs. So when you look at how I have my DNS defined, it's basically a unification between these two atomic filters. When we look at how I have my servers filter defined, it's unification of these two relational filters. And when I look at server infrastructure, it's again unification of another two servers or another two atomic filters in this case. So if I want to create a filter that will describe everything else which is outside of my internal LAN, I can say a new filter. I can give it whatever name I want. I'll say I want to do a relational filter, and I will use the operational invert my LAN, and it will automatically create a filter of all the IPs that are not defined as my internal LAN IP addresses just by inversion of one of the atomic filters that I've used. So now when I change the atomic filter, it will be automatically propagated to all the relational filters where this atomic filter is being used. So this way you can rationalize your filters. So let's move on in concepts. The essence of anomaly detection system is detection method. So detection methods are something that knows how to recognize specific set of anomalies in the network. In detection methods, we implement different kind of algorithms to analyze the network traffic and report on network events, anomalies, attacks, whatever we find as a malicious behavior in the network. But detection method as such is just a prescription. It does not do anything unless you create something called a method instance. Method instance is really executable representation of the detection method that has a specific configuration, is applied on specific data feeds using specific filters. So this way, you're simply telling ADS what to do and what kind of detections shall be applied on what kind of data using what configuration. So this is the relationship between the detection method and method instances. So logically, one detection method can have multiple method instances that are assigned to different data feeds with different configuration. This way you will achieve different, for example, different sensitivity of the detection methods in different network segments. There is also a term called submethod, and submethod is something that specifies in more granular detail what exactly the detection method has identified in the network traffic. Let me give you an example. There is when you take port scanning as an example, there are different ways how you can scan the network. It can be TCP scan, it can be ARP scan, and these are very different things. So these different behaviors in the network that all fit into the port scanning category are actually distinguished by different submethods. So when something is detected, you have a detailed information which specific behavior, which specific submethod triggered the detection, and you still have a reasonable level of grouping of those events into the detection methods. So we also discussed the concept of method instances. Here is a summary, just to reiterate on this. On method instances, you have different configuration, different parameters, different baselines, and this method instance is something that is executed against your data. Per method instance, you can even override specific global settings like what kind of history of events you want to keep in the system. So this way you may keep a longer history of events in some critical segment of the network, while for others you're just using the baseline. So that's additional benefit of method instances and what you can do with those. Now, what the method instances are producing? They are producing events, as you would expect, and event always represents a specific malicious behavior in the network that was detected. And these events provide, based on the event type, different, or based on the method, different information, different details. You can find those details in the user guide. Each event is referencing method, submethod, method instance, and data feed. So you know exactly which method instance detect this event on which data feed. So there is absolute clarity where this event is actually coming from. Each event has always one event source, an IP address, and can have any number of event targets. So basically a list of IPs. What we're also doing, we're mapping our events to the MITRE ATT&CK framework. So what we are doing is we're providing information on specific attacker tactic and technique that corresponds to the detected events. And that assignment is dynamic based on the method type, based on the IP addresses, so it can evolve over time as the event is progressing in your infrastructure. And last concept, before we jump to the next live demo is a concept of so-called false positives. So false positive is a mechanism how you can tune the detection and how you can explain the system that you have some exceptions, like don't tell me this is a normal behavior in my environment. Let me give you an example. So let's say you have IT infrastructure monitoring in place, and the purpose of that IT infrastructure monitoring is to continuously scan your infrastructure and check on availability of different systems, different IPs. So that IT infrastructure monitoring will most probably trigger an event very quickly. And this way you can say, don't tell me this in my environment. It's normal, it's expected behavior. So you will create an exception and the system won't detect the same event again. And you can be very granular in the definition of your false positive. You will always tie it to the detection method instance, data feed, and you can add additional parameters like source or destination IPs or even sources, even targets. And you can even work with autonomy systems or host names to exclude specific traffic from detection. So what we are going to do now, we will review false positives that I have in my system, and we'll look at some options how you can create those. We'll create a false positive that will exclude traffic with Microsoft Autonomy Systems from the upload detection method. So I'll move to live demo, go for false positives, and let me show you what I have here. So one exception that I'm saying, because I'm using Office 365 in this environment, that I'm actually good with uploads from my environment to everything that includes SharePoint.com in the domain name. So it's defined as for upload method whenever source is in my LAN, and even target is whatever, but it needs to be this specific host name. And I can see how this rule is actually triggering in last 24 hours and in last 7 days. So you understand if this rule is still being used or not. Also, there is a description that explains the purpose of that false positive rule. So when I want to create a new one, I can say, okay, so any upload from my internal LAN to autonomy system. So I need to enable advanced filtering parameters, and I will say Microsoft, select all, and add those here. I probably don't want these strange autonomy systems that I'm probably not going to have in my environment, so I can adjust it, and I can create my false positive rule that will basically exclude traffic defined by this filter, if you will, from the detection for the upload detection method. So that's how granular you can be in the definition of your false positives. So let's jump back and move to the last concept that it's important to understand before we go to traffic processing. The concept of perspectives is created as an assignment of priority for the events. You may be used to the fact that event has just one severity or one priority. But in ADS, it's different. You can define as many perspectives as you want, and this perspective will assign a priority to event based on different event parameters and characteristics. So perspective will always take into consideration which method, submethod, instance, data feed, or even IPs that are involved, and will provide a final priority for the event, critical, high, medium, low, or informational. So then when you are analyzing events, you can select a perspective that you want to use to understand those events. And this way, there can be a completely different priority set from network security perspective, different priority set for network operations, or there can be a specific perspective for alerting events to email or alerting those into a log management system through syslog, for example. So that's the concept of perspectives. Let's move on. Architecture and data processing. So in a nutshell, how it works is that the network telemetry that is being collected on the Flowmon collector is passed to ADS in real time for processing, and the events are detected on the fly. So event can be created really anytime based on how the data is being accumulated in the anomaly detection system. And these events are not one-off activities. These events are open in the system and they are updated. So if that behavior in the network is actually still happening, if that event is still progressing, that event is open and is being updated based on how many data has been transferred or based on new IPs that are involved in the event. So this way, we're reducing the number of individual events that are being generated because these events are not one-off activity. They are detected, they are updated, and then they are closed if this network activity is no longer happening in your environment. Of course, the results of the detection depend on your configuration of method instances, false positives. So that's something we will look at the next slide. There is a concept of a timeout that dictates when the event is considered as closed and will no longer be updated if the activity is not happening in the network. So that means that when the activity will happen again, new event will be created. So that's the life cycle of these events. And also, important thing to add is that any event actions that are configured as automatically triggered are happening when the events are detected, not when the events are updated. So in the first moment when the event is detected, it triggers all the actions that it's supposed to trigger. We'll also talk about triggers in a few minutes. So let's dive deeper on the different layers, what is going on. So first thing is data pre-processing. So at this stage, before we even apply the detection algorithms, we do things like flow pairing. So from unidirectional flow records, we create a bidirectional flow to understand who is a client, who is a server, so we can have the detection with better accuracy. There is an optional deduplication available because when you monitor a complex environment, you may have duplicate flows from different locations, but you want to avoid analyzing and processing these flows in ADS because that will impact the sensitivity of the detection method. So there is an optional flow deduplication feature. And other things like correcting obviously wrong timestamps or even correlating traffic before and after proxy. So this is where all the pre-processing is happening, including application of false positives to exclude specific traffic from specific method instances. And In the next step, this pre-processed data is actually reaching the detection methods, and individual instances of detection methods are applied on the data. As a result of the detection is event, of course, that's either created as a new event or updated existing event. At this stage, perspectives are being applied on events. So all the events will get assigned priority based on the definition of perspectives. And once this is completed, the last step is to make the events available in user interface or make the updates available in user interface. And of course, trigger all the event actions that are defined. Couple of remarks on how perspectives are actually evaluated. As you have seen the definition of perspective, how the event priority depends on the method, submethod, IP addresses. The definition of the perspective may be pretty tricky. So that's why this logic of evaluation of the perspective rules comes into place, and it behaves in a similar way like evaluating the firewall rules. Once the firewall rule match, the traffic is discarded, for example, and there is no more processing. So what the perspective does, it's all the rules within the perspective are sorted top down from highest event priority to lowest. And whenever the event will match the rule, it will get the priority assigned and the evaluation of rules within the perspective for that specific event stops. So let me give you an example. You have a general definition saying port scanning is medium priority. But you want to say that everything that happens in my critical internal network subnet will get higher priority. So you say, and scanning in data feed LAN and even target servers will get priority critical. So once the event goes in, and if it match the critical rule, then it's critical, and other rules are no longer evaluated. But if that event does not match that critical priority, then it will go down the evaluation chain and it will get eventually the medium priority assigned. So when you understand this logic, then it's easy for you to define perspectives, because you will start with, this is the general base priority I want to have, and these are some exceptions that I want to rate higher. And that's it. Perspectives are very important because perspectives control everything. You use perspectives as rules for what shall be sent as an email alert, what shall trigger packet capture, what shall go to SIEM through syslog. You can even use perspectives to control user permissions. So that's very essential concept in the anomaly detection system. So let's take a look at a practical exercise. So I want to say that in my perspective code security issues, ARP scans are critical while everything else is kept on the high priority. So let me show you how I'm going to do that. I'll go to perspectives and I will edit this perspective called security issues. And when I want to do this more advanced configuration operations, I will switch to the advanced form. And this way I can see that port scanning is in general defined as high priority. So I'll go to critical and I say that scans in submethod ARP scans will be rated as critical. And that's it. That's all I need to do. And now when an event will enter the evaluation of these rules, and it will be a port scanning detected by the submethod ARP, it will have the critical priority assigned. And if not, the evaluation of the rules will continue and it will get the high priority assigned because scans in general are rated as high. So this is how you can tune perspectives. Let's switch back and let's talk about triggers. So there are multiple different triggers. Obviously, there are notifications, email notifications that are either designed for a human consumption or some machine processing, which means that you can select a format of that notification depending on who or what will be the consumer of the events. Then you have the option for event logging for third-party systems like log management or SIEM using syslog, or you can even do SNMP trap if needed. This way, the events are automatically delivered to these third-party systems. Then together with Flowmon Packet Investigator, you can do triggered captures, which means that whenever an event is detected, packet capture is triggered automatically. So you will have your forensic evidence in form of PCAP that documents the malicious activity, and this is attached to the event. And last option is an active response to an event where we provide a general scripting capabilities which you can use to invoke a third-party API. So you can, for example, control a firewall and say that specific traffic will be blocked, or you can control some network access system. So you can say that this specific device will go into a quarantine VLAN to get examined, to get all the updates, and then you can return back in your internal network environment. So these are the options that you have available, and these are all controlled by perspectives. So let's do another exercise. Let's configure email alerts for events that are either critical or high. So I'll switch back to anomaly detection system and go for email notification and create a new one, which will say, okay, this is some name that's not so important. It's using perspective called security issues. It's active. And what's going to do, it will use this perspective and it will report only events that are high or critical. And I've also mentioned different formats of emails. So as I want to send it to a human recipient, I'll take the full HTML formatted email, click save, and that's it. So from now on, I'm going to receive email notifications about all critical and high events based on the perspective called security issues. Let's move on to the last part, which is about tuning the detection capabilities. I will start with some ground rules. Essential first step is to understand what you are actually monitoring. So you should start not in ADS, but you should start with probes, with routers, with network topology to make sure that everything is actually deployed in the right places in the network and you see the traffic that you want to see. You don't have any duplicate traffic, you don't have any blind spots. So you need to understand what actually is being monitored. Then the purpose is not to detect as many events as possible, but to detect only relevant events. So you don't really need to use all the detection methods that are in the system. Use only those that are relevant. Let me give you an example. So there is a specific detection method to recognize TeamViewer behavior, TeamViewer system in your environment, that some host is being managed through TeamViewer. If that is your standard IT practice, if that is something you're using in your environment, it does not make any sense to detect it. So you just disable the whole detection method and avoid these events to be generated. And last remark that I have is about using false positives and filters. False positives are not a mechanism how to fix a wrong filter configuration. So if you, for example, if you are missing a legitimate DNS server in your config, you should not create a false positive rule for that, but you should add that missing DNS server into the filter that defines DNS servers. So that's first, think about adjusting filters, and then if it's through an exception, then create a false positive rule. Another thing to consider is data quality. That's important aspect, and if there are issues with the data that you are processing, you cannot expect that you will get great results. So basic things are timestamps, accurately defined time on the sources of the data, on routers, on probes. If you are using routers or switches, there might be quality issues like missing TCP flags, which makes it more complicated to detect some subset of anomalies. Sometimes when you configure flow export, you just configure one direction of the traffic, you're missing part of the traffic. All these issues need to be reviewed and understood to avoid, wrong data will lead to wrong results. There is another consideration which is called sampling. If you are using routers or switches as a source of the data, there might be sampling on the packet level, which means that you will only see a fraction of the traffic, and that will, of course, impact the detection accuracy. On the other hand, our probes will provide non-sampled, highly accurate data that will lead to best results in the anomaly detection system. There are some options how you can fix some problems like timestamps or the duplicate flows that we discussed already, but there are of course issues that you just cannot fix on the Flowmon system, and you need to go to the flow source and configure it properly. To simplify this troubleshooting of flow data quality, we have embedded a command line tool to Flowmon Collector that is available there to automatically analyze the quality of flow data that you are ingesting. And that tool will be able to check all these different issues and flag the issues that it has found in the network traffic based on the RFC standards, issues in the flow data, and will basically give you an evidence what is wrong in the configuration of flow export. It's described in our user guide in the documentation how to use this tool to assess the quality of the data. When you are using probes, you don't really need to be worried about this because you get the best flow data you can get already. You just need to be mindful about configuration of the port mirroring to make sure that you are mirroring the right traffic to probes. Then for filters and for false positives, we already discussed some of those best practices. So for filters, I recommend to think about the filter structure first, build it bottom up using atomic filters that are then composed to relational filters. And you can also think about some naming conventions. In my example, you have seen that I've started for all the relational filters with a prefix small letter R. But it's completely up to you. Just think about some conventions that you are going to use in your system. And I also recommend using nodes for individual IPs or IP ranges, so you will better understand what it is, and also other users of the system will better understand what it is. For false positives, before you really introduce a false positive rule, consider updating filters. Maybe you can sort your issue with filter update. Also, you don't need to define the false positives in advance. Just do it as you working with the system. There is a context menu called mark as false positive that you can use on each and every event. And this way, when you investigate an event and when you see, okay, this is fine in my environment, I want to create an exception, you can click on the event and say mark as false positive. Always include a description why you are putting a false positive rule, so then you will remember it, you will understand it, and others will as well. And also in false positives, I strongly recommend using filters, not direct IPs, because then when you need to do a change of the IP address, you can just do it once in the filter and it will be automatically propagated everywhere. And when you are defining a false positive rule, think about the scope. You probably don't want to make it like general false positive rule for all the traffic. Maybe it's specific only to a certain data feed or specific only to certain method instance. So this is something to consider and make the false positive rule as specific as possible, so you don't exclude traffic from the detection that you don't want to exclude. Last piece is adjusting the configuration of method instances. So basically tuning the sensitivity of the detection methods. There is no like general guidance that is applicable to all the methods, because these methods are very different, have different parameters and different recommendations how to configure those methods. So we're providing a detailed description in the user guide of each and every method, where we are explaining how the method works, what the method detects, what kind of submethods the method has, and what kind of parameters. And we also provide some recommendations how to configure these parameters. So I recommend to consult the user guide to understand specifics of a particular detection method. Let me show you an example. So let's say we have this DNS query method that is doing adaptive baselining of individual clients in the network, how many DNS requests they are actually issuing towards the DNS servers, and you want to adjust the method instance and look at the sensitivity. You want to reduce number of events. You don't want to be that sensitive. So let's move to the user interface again. I'll go to methods and I'll filter for the DNS query method. And I have here an instance called default. I go edit that instance, and here are the parameters. So there is always common methods, the common parameters for method that is always available, always the same for all the detection methods, which is how long you want to preserve events detected by this method instance, and what is the update interval and inactive timeout of the event. So this means that every 5 minutes, event is updated when the activity is still happening in the network. And this means that if this event is not updated for like last 15 minutes, it's automatically closed, and that event is considered as ended or completed. For the method sensitivity, in this method, we have minimal count of DNS queries from a single station that are of our concern, and this is happening in a moving time window, sliding window over time. And there is a multiplicator, so we want to be notified if there is any device in the network that is doing 3 times more than what is normal in that network, what is average. But still, the minimal that it needs to be, it's like 1000. So this way you can tune up the sensitivity and you can say, okay, I want to be not 3 times average, I want to be this like 5 times average, and it needs to be at least 2000 DNS queries, not 1000. So this way you can adjust sensitivity to minimize the number of events that you will be producing. Okay, we're getting to the last slide, I believe, which is something we didn't discuss yet, and it's use of indicators of compromise. There is one specific method called blacklist, which is using known reputation databases, so known malicious IPs domains, to detect communication in your environment with those malicious devices. And it also makes sense to adjust the detection using these reputation data. So, for example, if you will see attacker being active, a known attacker being active in your DMZ, that's very much expected. DMZ servers are published to the internet, so it's absolutely normal that attackers are continuously browsing the internet and are reaching those servers. On the other hand, if you see such a behavior in the internal network, it means that your device is actually contacting a known attacker, which is a suspicious activity. So you can adjust which method instances will be using which reputational data to make sure that you will produce only meaningful events. And you can also, what you can do, you can use your own custom threat intelligence data. You can use your own custom reputation databases, either in some files that you publish internally, or you can even connect to a system called MISP, which is an open source threat intelligence sharing platform that's all supported out of the box. So you can customize and add your threat intelligence data into ADS. Okay, that's whole content for today. I know it was a lot, but I hope it was useful for you to understand in more detail how ADS works. And now it's time for any questions. So if you have any questions, type them to the chat, or not, sorry, not to the chat, but to the question section. And I will be answering those as we go. Okay, I see there regarding filter import, how you can add nodes for specific records in CSV file. Actually, you can. That CSV file with IPs, I think it has a specific structure. I don't know it on top of my head, but I know who asked the question, and I will contact you after the webinar and provide you very specific answer to that question. Any other questions? Do we have to check the compatibility between Flowmon ADS and EDR? I wonder what kind of compatibility. EDR will take it from the endpoint perspective and will send detected events to some log management or SIEM. Flowmon will do it from the network perspective and send the events to log management or SIEM where it's going to be consolidated. So I don't see any need to check compatibility between Flowmon and endpoint detection response system. It should work together or next to each other regardless of the vendor. Okay, so if there are no more questions, thank you. I hope it was useful. And in our next webinar, we will switch context again and move to network operations, and we'll look at network performance metrics. I see one more question here. Will it be possible to set false positive rules based on the device name in the future? I don't think so, as the device names are not part of the initial network telemetry that we're ingesting and processing, are derived from DNS, can change. I don't see this as something we will implement. Can ADS process IPFix from LoadMaster? Yes, of course, because IPFix on LoadMaster is produced by Flowmon Probe that is running on the LoadMaster. So it's a probe feature of the LoadMaster, and it is exactly the same probe as dedicated Flowmon Probe that is generating that IPFix traffic statistics. So absolutely, we will process network telemetry from LoadMaster as our native. Don't see any more questions. Thank you, everyone, and see you on the next webinar. Bye.